The U.S. Department of Energy and contractor Central Plateau Cleanup Company are reducing the risk in the 200 East area of the Hanford site in Washington state. Engineers have developed a safe and compliant process to remove 1,936 highly radioactive cesium and strontium capsules from underwater storage inside the Waste Encapsulation and Storage Facility, or WESF, to a safer dry storage configuration. In the 1970s, cesium and strontium were removed from waste tanks at Hanford to reduce the temperature of the waste inside of the tanks. The capsules represent about a third of the total radioactivity on the Hanford site. While they are currently in a safe configuration, WESF is an aging facility. Transferring them to dry storage would eliminate the possibility of a release of radioactive material in the unlikely event of a major earthquake that might result in the loss of pool storage water and subsequent overheating and breach of the capsules. Teams of well-trained personnel will accomplish this work safely and compliantly, benefiting from the lessons learned and proficiencies gained from training with the equipment at a full-scale, non-radiological mock-up. To begin the removal process, workers on a catwalk will use long-reach pole tools to access the capsules that are stored under 13 feet of water, which provides adequate radiation shielding for the workers. Workers will retrieve the capsule and move it to the transfer chute connecting to the hot cell, or G cell. From outside G cell, workers will use manipulator arms to bring the capsule near a shielded window to inspect the capsule for damage. They will also verify the capsule's identity to ensure the correct capsules are loaded in such a way to comply with the capsule storage thermal analysis. If operators find a damaged capsule, they will place it in a larger overpack capsule. Then, workers using the manipulator arms and a special insertion tool will place the capsule into a universal capsule sleeve, or UCS. The UCS can hold up to 6 capsules. Once the UCS is full, the air inside will be displaced with helium, which helps dissipate the heat from the capsules. Following a successful leak test, the UCS is ready for transfer to the truck port. Using cameras, workers will guide a grapple over the UCS, hoist it out of G-cell and into the Shielded Dry Transfer System, or DTS. The DTS is a large shielded cask that will transfer the UCS from G-cell into the WESF Canyon to the truck port, using a 15-ton crane. In the truck port is an 11-foot tall, 10-foot diameter cask shielded with reinforced concrete. In the cask is a storage container capable of holding up to 22 universal capsule sleeves. A robotic welder will seal the lid of the inner storage container. The air will be removed, and then the container will be filled with helium to aid in keeping the capsules cool. Once the helium is in place, a second outer lid will be placed on the storage container and welded in place. Once the loading process is complete, workers will open the truck port roll-up door and remove the cask. The equipment used to transport the cask has been repurposed from a previous DOE project, avoiding millions of dollars of cost. The Vertical Cask Transporter, or VCT, a specially designed hydraulic lift unit, is used to lift the cask. The tug will tow the VCT and cask to the capsule storage area, a 90-foot by 90-foot secure outdoor storage pad located approximately 1/4 mile from WESF. The cask will be placed on the pad and will be connected to a temperature monitoring system. The cask will be placed in one of the 25 locations on the pad. Once the final capsule has been retrieved and the final cask has been placed onto the storage pad, WESF can be prepared for demolition. These cesium and strontium capsules will remain in a safe and passive condition until a permanent storage location is available.